Let's play Redactle for Friday, September 16th, number 163. Before we get started, I just want to show one of the features of Redactle Unlimited that's pretty cool. You can create custom games for your friends by going to any Wikipedia article, copying the link, then back in Redactle Unlimited, if I say new game, single player, but I'm going to choose custom, and now I just paste in that URL, and it says, are you sure you want to start a new one? And now this link here, beginning with the Q573813, is unique, and so you can send that to your friends to challenge them if the daily game is not good enough for you. All right, but let's go ahead and play the daily game for today. Oh, it's still showing 162. Let me just reload here. New game, daily. Am I sure? Yeah, here we go. So we have a hyphenated word, 3-1195, R6, 3115. Interesting different word order. And then I suppose also known as. And then are these scientific terms? Well, let's go ahead and put in our, also known as 251-5 or 2-11-5 is a 9-7 in maybe in which as the 3-1, no, in which you, in which are, no, we do have R, in which 3-6, in which 3-6, and then 6 and 10 in italics are 8-9, the 8 of and 7, and then that's either ED, IE or EG, it's IE, 5, on the 5. Okay, I have no idea what area of knowledge this is. The 3 of 5 of 4, 7, 4, 10, 5, with 11, 9, 5, 6 as the 9, 7 of a 9, 5. Well, what are a common three-letter hyphenated suffixes? I'm thinking of pan. No. How about ill? No. Mid. Whoops, what did I do there? Lost my focus. There we go. Mid, sub. No. What could that be? Maybe USA dash, no. The 3 of 5, maybe the aim, no aims. The something, well, let's get some common words out there. Be, being, been, has, had, have, having. Yeah, it's a bit hit and miss today with these common words. We matched one. How about once? No, only. And let's try 2. Oh, 2, of course, I should have thought of that. So 2-1195, R6, 2-11-5, 2. No, I'm not getting that at all. How about were? One were. This, that, these, and those. The 2 11, 9, 5 for a 14 of the 7, 3, 9. For a subsection, some long word meaning that. But what was the 3 be? The 3-letter word. 2, 11, 5. So maybe or can be. Let's do might, must, could, would, should. To something can be seen. Yeah, as a 10. Maybe a projection. Oh, now that's ridiculous. I haven't had a good word like that in a while. Can be seen as a projection of the something onto a plane would make sense. I'm wondering if this is some map projection. Maybe two-dimensional. Yes, two-dimensional 9, 5. Is it space? Is that the 5-letter word? Yes, two-dimensional something space, also known as 2D space, I suppose. 2 space, is it called? Yes. I don't know what the 2-character dimensional, would it be II? No. Is a 9, 7 in which 2 maybe planes? No, 2 points? 2 something. Are we going to have axes? Yeah, how about axis singular? We may have X and Y. Yeah. Let's see. It is thought of. Yes, and is this, however, as a something space. And the 2, 10. And the 2 are 6, 6, and 5. No, I'm not getting that. Okay, we have history, I suppose. What is this I? Is it some king the first? No, through is something I through 2 and 2 of somebody's something 5 with two-dimensional 8. The 11, 7. Consists of something of 6 and 5, 11. And the 5, 5 in which 9 are 5 have the same. No, I'm not getting among something. Is other in there? Yes, among some other. Among many other. Okay, among many other facets. No. Maybe later. Yeah, the plane was 9 in a 2 6, 9, 10, 6. I wonder, Mathematica always seemed to be in one of those texts. No, just mathematics. No, one mathematics. In mathematics, 8, 8, which I think we had 8, 8 before, also called 9, 8. Maybe represent. No, represent. 5, 5 in two-dimensional space by means of two perpendiculars. No, that's too long. Let's try perpendicular though. Oh, there we go. Two perpendicular something axes are, which never meet each other, of course. No? Which 5, 4 each other. Oh, well, they do actually, of course. They do meet. I'm thinking of parallel lines never meet, but perpendicular, yes, which not intersect at the origin, which not intersect. Well, let's do intersect. One intersect, which cross each other, maybe. Yeah, at the origin. They are usually not called or named X and Y. Parallel. No? Don't have any parallel. Interesting. Eight to these axes. The 8 of 3, 5 in two-dimensional space is 5 by, well, let's do line and angle. Its angle, okay. Its distance of that. Did I do point singular? No, I did not. Maybe every point. Yes. So maybe describes every point. Yes, by means of two coordinates is 11. What's our title? Two-dimensional something space. Maybe planar. It could be the 6th letter. Well, we do have 3. I'm still baffled by that capital I in the history section. Could it be a typo? Oh, in a so-called 9, 10, oh, so it's not a treatise, it's a something. Well, maybe it's a theory. We have that. How about theorem? I always loved theorems when I studied mathematics. Theory in something theory. What is that theory? A planar 5 is a 5 that can be, I'm thinking inscribed. No, that's 9. Can be depicted. No. I.e. it can be something on the plane in 4, 3 in such a way that it's it's 5 intersect, so is it it's lines? No, it's something intersect only at 5, 9. In other words, it can be drawn, it can be drawn on the plane, in such a way that no, I want to keep wanting to do lines, and no something cross each other. Such a 7 is called a plane 5, or a planar 9 of the 5. A plane defined. Oh, this 5 letter with a 7 from every 4 to a point in a plane, and from every something such that the various no what would you call the points at the far end of a line? No, not getting it. And then of course we have C also in physics. No, that's only 7. In science, in algebra, we do have 3 algebras. Okay, in 6 algebra. Is something in 6 algebra. And maybe where? Yeah, where the 4 of 12 is 7. The plane has 2, 10 is 11 of its 5. I wonder if this is something to do with reflection. Reflected. No. By a 6, 11 of 2, 11, 7. Okay. We're probably going to have some maybe Greek letters here. Maybe not, but let's put in 1. A1, let's try B, B1, B2. The 3, 7 of 2, 7. Formula. One formula. Okay, so we have some formulas missing here. Which gives maybe, yeah, in 8. I'm just thinking, let's try linear. We do have some linears. Oh, it was linear algebra. There we go. And all 4 linears appear in that paragraph. Other 6. Have I done dimensions plural? I don't think so. Let's try dimension and dimensions. Okay. The 11 in 2 dimensions is a circle, maybe? Aha, oh, okay. And then maybe other shapes. Yes. 3-6. Do we have squares? No. Are shown below. The other, no, I did other, the 5-3. The 8-6, and then in curly brackets. Oh, I don't think I've seen curly brackets before, have I? I don't remember them. A7, and then one character in italics, -3. Maybe rectangle. One rectangle. Maybe another. Yeah, another 12 way of drawing. No. Of not defining is no, where the 4 of 12 is 7. In the 9-8, in the something of linear algebra, the plane is two-dimensional because every point in the plane can be well, let's do rectangles plural. Nope. How about triangle? One triangle. The history, okay. The 3 of the 6 in a triangle. Oh, the sum of the angles, yes, which is 180, right? Let's try 180. Nope. And the 5-5, in which 9 are 5. Maybe alike? Nope. By a 4 of 9 coordinates, to 2 equal? No, oh, we do have equal. Yeah, I'm not sure I'm getting any closer to getting this 9-letter word. Even if I could get the 6-letter, I think it would be a help. Did I do planes? Oh, no planes. I did do it, but I forgot the word none. How about identical? No. Is there a law about this? No. Have we done length? Aha. And width? Okay. As a 9 space. Oh. Um, a projection of the 8, 8 onto a plane. Oh, maybe the universe? Yeah, the something universe. And then what's the more general form of a rectangle called? I'm going to have to pause and rack my brain for that. Oh, of course, a polygon. When your parrot leaves you. No polygon. No, let's try polygons. 4 polygons, that's good. The 7, 7 are 7. 1 and 7, 5, 2 can be something. Polygons in 3-9. So that's not 2, and it's not 1. Like a 2, 6, 2-5, or 5, 8, 8. And we have 3-6. And something divided by something. They are called 4 polygons, and 5 the same. Not characteristics of the maybe regular. Oh, okay, regular is there quite a lot. A regular, what's that first one? 1-3. The regular 7 and regular 5 can be considered, yes, can be considered 10 regular polygons. What's the 10-letter word? And there, well, we have some theirs. Okay. Only at there. Planar. Oh, maybe curve. Okay. Such that the something points of each curve. What is this theory called? Okay, we have references, doesn't help me, but its dimension is something by the rule. No, I did rule. Oh, no, I didn't. Maybe giving a space. Oh, we do have one giving. They are usually maybe labeled. Yes, X and Y. Something to these axes. The 8 of, any point. Let's do all as well. Is found, maybe? No, is something along the something axis. Well, I had a good start, but I've definitely slowed down now. You sometimes see the word real. Yeah, oh, there we go. The something of 5 of real 7, real 10 space. Of real something. Another complicated way of I'm thinking, imagining or considering where the 4 of 12 is 7. Oh, length of a rectangle is independent of its width. In the something something. Um, Two independent 7. Not getting this. What could the 9-letter word be here? Is the 9 the something points? Doesn't seem right that you could have a word there. Is the blank the something points? The 9 of a 6A is 7 by, not that, in this 9. Well, let's try radius. One radius. Okay, I think there may be some Greek letters that are missing, which may be why that other line didn't read right to me. The something in 2 dimensions is a circle, not the sphere. And then what's the 9? Oh, sometimes called a 1-6 because it is a one-dimensional 8. Well, if it's one-dimensional, then it's just a line, right? Well, maybe equation. How about equations? No. It has the length 2, 1, and the something of its 8 is I wonder if topology is one of the areas. Yeah, so it is in topology. being the something 12 2 dash. By the fact that, yes. But not 6 9. Okay, and then what is this 5 theory? Not game theory, string theory, shape theory. Ooh, somebody's theorem. Here we go. Who's a mathematician with 5 letters? So let something be a 10 9 9 6 6 6 curve in a plane, and let something else be the 6 7 by something if these two things are 9 of x y, not independent, are something. Oh, no, parameters is too long. But let's put it in anyway. 1 parameters defined on an 4 6 10 something, where the 4 of 11 along something is, oh my goodness, 16 letters. In which two, so parameters in the very first paragraph. Is in which 2 6 are necessary, maybe? Essential. 2 parameters are something to calculate. No, that's 10 letters. And it's not spelled like that. Oh my goodness. Let's try that again. No, calculate. These are something to 9 the 8 of an 7, i.e. point. So what's another word for point that begins with a vowel and has 7 letters? Maybe element? Oh, that surprised me. The something of an element. Location, location, location? No. My goodness. Let's try flat. Oh. Let's try project. Oh. For a 14 of the 7C dimension. And then what is this 8 universe? This meaning, I suppose, 3-dimensional. Oh, maybe, okay, so history, I think I've worked out that I, and I'm sure you thought of it earlier, but I think it's books 1 through some number and some extra one of Newton. No, it's probably earlier. Euclid. Yes, Euclid's. What was his work called? Maybe dealt with. Yes, dealt with 2-dimensional something. Maybe including. No, we do have one including. something of angles and 5. Area, okay. Maybe the cases. Yeah, and the something cases in which 9 are equal, among many other topics. Yeah. Later, the plane was something in a so-called 9-10-6. That 9 each point 8 in a plane by a 4 of 9 coordinates. I gotta think some of these 9-letter words are the one in the title. 8 in the same 4 of length. Each 9 line is called a 10 axis, or let's do horizontal and vertical. No. Let's do vertex. One vertex. They're called something. Polygons and something. Not in addition. Well, let's put it in anyway. No, in something. Well, maybe it's an area of mathematics. For any 7, 6, and then a 1, is that another variable? 5 are something, so it's not 1 or 2, or have we done we've done 3. Yeah, no, we haven't. Let's make sure I did 2. Oh yeah, such that something is less than something divided by 2. Oh, is this going to be acute? No. And obtuse? No. They are called 4 polygons. So what is something in 2 dimensions is a circle? I mean, I'm thinking sphere, but maybe it's hemisphere. Oh, are we going to have parabola? We do have the parabola down below. The 7, the parabola, and the 9. Including, this must be the 3. No, the somethings. The 5, 8. Oh. No, I'm not getting this at all. Let's try some other mathematical words like congruent. No. Have we done intersect? Yeah, way back. Oh no, not way back. But yeah, it was way back, sorry. Okay. Which something, a point in in terms of its distance from the origin and its angle, something. Did I do relative? No, so there we go. That's good. And its angle relative to a 9, 9, 3. Um, let's try sine, cosine, tangent. No. I thought I did there, but maybe not. Oh, okay, there are something, maybe, no, not infinitely. Oh, it is. There are infinitely many something, the polygons. The 5, 3, regular 4 are shown below. Regular ones. Okay, the major, main, the 5, 3. No, I'm not getting that. Let's try some other letters. Did I do C? Oh, we have 11 C's. Oh, okay. In line 9 and 6, 9 is calculus. Only 8 letters. We do have one calculus. Hmm. When, then, hmm. Give, yeah, okay, give the 9 of C and something. Usually defined as 11th theorem of line 9 maybe says that a line 8 not passing through a something something can be 9 by 10 by calculating. No. Measuring. No. Let's try measure for measure. No. At the 9 of the curve. Is that a word like azimuth? Oh. Yeah, let's look at our other C's. I think it's all going to be just C as a variable, which doesn't really help me. And who is this 5-letter guy? No, so C doesn't help me in calculus. The 8 is 5 by. Oh, let's try differential. No. There are 2 gives. Let something then. Okay, how about infinitely? There exist, maybe? Yeah, infinitely many 3-6 regular something in 2 dimensions. Well, we did see, let me go back to do, well, we've done D. Let's try E. Actually, did I do D? I did 2D and 3D. No, I didn't do D. Let D be the 6, 7 by C. Let C be a continuous. Oh, we do have continuous and have continuous 7, 11 there. Then where the 4 of 11 along C is that 16-letter word. Oh my goodness. Okay, how about F? 2 Fs. Okay, for a 6, 5 F. Maybe a force. Nope. In the 9 of something, where period or dot is the 3, 7. Oh my goodness, this is very tough. Yeah, I don't know if this is going to be so advanced that I've never heard of it, but usually when I give up, it turns out to be some common word that I could have found if I just kept plugging away. So I think what I'm going to do is just pause, start putting in some words, and then I will come back to you. Okay, I put in a few more words, starting with foundation, I think. And then I did match on fundamental theorem of line something. I then tried some other names and parts of maths. Finally, I realized I hadn't put in geometry itself. So it's two-dimensional geometry is in the history section. And then in geometry, 8 geometry, also called 9 geometry. Well, spatial is only 7 letters, but let's try that. No. Also called not sure what types of geometry there are. Okay. Okay, those are the only 4 mentions, so not very helpful. Nine. In 2 dimensions, there are infinitely many something, the polygons. The 5, 3 regular ones. Maybe 10? Nope. Something. And then what is this 3-letter prefix? Oh, non, of course. I forgot that common. Yes, non-Euclidean, maybe. Ooh, 9 letters. Could it be? Yes. Oh my goodness. When did I get Euclid? Because, well, yeah, it wasn't that long ago. But yeah, I should have thought of Euclidean. Bidimensional was the other 2 character, which 2 values called parameters. There we go. Books 1 through 4 and 6. Oh, Pythagorean. Oh, and Cartesian. I knew about that. Oh, and there's good old Fermat. Um, yeah, so coordinate polytopes. Never heard of that word before. Convex, degenerate, non-convex. There we go. Oh, the hyperbola, the ellipse. All right. Well, I'm glad that one is over with. Not one of my favorites of recent times, but I got there in the end. Way behind the other players who have gone, who got it with a mean guess count of 72 and a half. Took me 220. All right, well, that is Redactal. Thanks as always for watching and have a great day.